Welcome to the world of agentic design patterns, where artificial intelligence evolves from simple automation to intelligent autonomous systems. This video is your hands-on guide to building smarter, more capable AI agents. We'll explore how agentic systems perceive, plan, act, and learn, transforming the way we interact with technology. Whether you're a developer, researcher, or enthusiast, understanding these patterns will empower you to create robust, reliable, and innovative intelligent systems. Let's embark on this journey to unlock the next frontier in AI, where agents collaborate, adapt, and drive progress across industries. Artificial intelligence is at a pivotal moment. We're moving beyond models that simply process information towards systems that reason, plan, and act to achieve complex goals. These agentic systems represent the next frontier in AI. Just as design patterns revolutionize software engineering, agentic patterns provide a toolkit for building robust, scalable, and reliable intelligent systems. The metaphor of a canvas captures this perfectly. Developers now have powerful tools to create the next generation of AI applications, guided by practical, hands-on patterns. With great power comes great responsibility. As agentic systems become more capable, the stakes rise, especially in critical domains like finance, healthcare, and infrastructure. The book emphasizes the need for clear principles: build with purpose, anticipate failure, and inspire trust. Agents must be designed with resilience, transparency, and accountability. Clean data, well-defined APIs, and robust processes are essential. Ultimately, agentic frameworks are about augmenting human ingenuity, not replacing it. They demand humility, clarity, and a relentless focus on doing what is right. Think of building intelligent systems as creating on a canvas, not a blank space, but a structured environment where agents perceive, plan, and act. This canvas is the foundation for your intelligent applications, managing state, communication, and logic flow. Agentic design patterns are the brushstrokes that bring this canvas to life, offering reusable solutions to common challenges. Just as architectural patterns guide buildings, agentic patterns structure the logic and interactions of intelligent agents, making complex systems manageable and reliable. Its core, an agentic system is a computational entity that perceives its environment, makes informed decisions, and acts autonomously to achieve goals. Unlike traditional software, agents are flexible and proactive. Imagine a customer service agent that not only answers questions but anticipates needs, accesses databases, and interacts with other systems. Key features include autonomy, proactiveness, reactiveness, goal orientation, tool use, memory, and communication. These capabilities introduce complexity, but also unlock powerful new possibilities for intelligent automation. Agentic design patterns are not rigid rules, they're proven templates for solving recurring challenges in agent development. By applying these patterns, you gain structure, maintainability, and efficiency. They help you avoid reinventing the wheel for tasks like managing conversations, integrating tools, or handling errors. Patterns provide a common language, making your agent's logic clear and easier to maintain. They accelerate development and ensure your systems are robust, reliable, and ready for real-world complexity. Bring agentic patterns to life. The book uses three main frameworks: LangChain and its extension LangGraph, CrewAI, and Google Agent Developer Kit (ADK). Each offers a different canvas for building agents, from chaining language models to orchestrating multi-agent systems. By showing examples across these tools, you'll learn how to apply patterns regardless of your technical environment. The focus is always on clarity, practicality, and hands-on learning. AI agent is more than a language model. It's a system that perceives, plans, acts, and learns. It follows a five-step loop: get the mission, scan the scene, think it through, take action, and learn to get better. For example, an agent organizing your schedule will read emails, plan meetings, send invitations, and adapt to changes. Agents are rapidly becoming essential in business and technology, with the market expected to grow exponentially in the coming decade. AI has evolved from simple automation to sophisticated autonomous systems. Early workflows used basic prompts and triggers, retrieval augmented generation, RAG-grounded models, and factual data. Next came individual agents using tools, and now we're entering the era of agentic AI, teams of specialized agents collaborating to achieve complex goals. This leap in collaborative power is transforming industries and redefining what's possible with AI. Agentic systems can be categorized by complexity. Level 0 is a core reasoning engine, an LLM without tools or memory. Level 1 connects to external tools, enabling problem-solving beyond pre-trained knowledge. Level 2 adds strategic planning and context engineering, allowing agents to tackle multi-part problems and improve over time. Level 3 introduces collaborative multi-agent systems, where specialized agents work together, mirroring human organization. Each level unlocks new capabilities and challenges. The highest level, agentic systems move away from single, all-powerful agents to teams of specialists working in concert. For example, launching a new product might involve a project manager agent coordinating market research, product design, and marketing agents. The key is seamless communication and information sharing, ensuring all efforts align toward the collective goal. While challenges remain, this collaborative model is the future of intelligent automation. What's next for AI agents? 5 key hypotheses shape the future: the rise of generalist agents capable of managing complex, long-term goals, deep personalization and proactive goal discovery, embodiment and interaction with the physical world, the emergence of an agent-driven economy, and goal-driven, metamorphic multi-agent systems that self-improve and adapt dynamically. Each hypothesis points to a world where agents are more reliable, collaborative, and deeply integrated into our lives. The future belongs to large, generalist agents or networks of small, specialized ones. Both paths are plausible. Generalist agents can manage complex, ambiguous tasks, while specialized agents offer efficiency and ease of deployment. The leg-like approach of composing systems from expert agents promises flexibility and scalability. Ultimately, these approaches may complement each other, creating powerful, adaptable agentic systems. Agents are becoming proactive partners, learning from your unique patterns and goals. They move beyond following instructions to anticipating your needs, suggesting actions, and supporting your ambitions, even those you haven't fully articulated. This shift from reactive to proactive agents will make them indispensable allies, helping you discover and achieve new possibilities. Next leap is embodiment, agents operating in the physical world through robotics. Imagine asking your home agent to fix a leaky tap. The agent perceives the problem, accesses knowledge, and controls robotic manipulators to perform the repair. This integration of digital intelligence and physical action will transform industries from manufacturing to healthcare, bridging the gap between software and the real world. Highly autonomous agents are poised to become active participants in the economy, creating new markets and business models. Imagine launching an agent to run an entire e-commerce business, identifying trends, managing logistics, and adjusting pricing in real time. This agent economy will operate at speeds and scales humans can't match, driving efficiency and innovation across industries. Imagine a system where you simply state your goal, and a dynamic team of agents figures out how to achieve it. These metamorphic multi-agent systems can create, duplicate, or remove agents as needed, constantly tuning their instructions for optimal performance. This marks a shift towards self-improving, goal-driven systems that can automate entire workflows and adapt on the fly. Prompt chaining is a foundational agentic pattern. Instead of tackling a complex problem in one step, break it down into a sequence of smaller, manageable subtasks. Each step is handled by a specific prompt, with the output of one feeding into the next. This modular approach makes the process more robust, interpretable, and easier to debug. It also enables integration with external tools and knowledge, expanding the agent's capabilities. Using a single, complex prompt for multifaceted tasks often leads to inefficiency and errors. The model may overlook instructions, lose context, or propagate mistakes. Prompt chaining addresses these issues by decomposing the task into focused, sequential steps. Each step is simpler and less ambiguous, reducing cognitive load and improving reliability. This approach is especially valuable for tasks like summarization, data extraction, and multi-step reasoning. Reliability of a prompt chain depends on the integrity of data passed between steps. Ambiguous or poorly formatted output can cause downstream failures. To mitigate this, specify structured output formats like JSON or XML. This ensures data is machine-readable and precisely parsed, minimizing errors and enabling robust multi-step systems. Prompt chaining shines in real-world applications. Information processing workflows, complex query answering, data extraction, content generation, conversational agents, code generation, and multimodal reasoning. For example, an agent might extract text from a document, summarize it, identify key entities, and generate a report, all through a sequence of focused prompts. This pattern is the backbone of sophisticated, multi-step agentic systems. Implementing prompt chaining is straightforward with frameworks like LangChain and LangGraph. You can chain together prompts and processing steps, passing outputs as inputs to the next stage. For example, extract technical specs from text, then transform them into a JSON object. This modular pipeline approach makes your code more maintainable and your agents more reliable. Context engineering is the discipline of building a rich informational environment for your AI agent. It goes beyond prompt engineering by incorporating system instructions, retrieved documents, tool outputs, and implicit data like user history. The quality of the context you provide is a primary factor in enabling advanced agentic performance. Context engineering ensures your agent has a well-rounded understanding of the user's intent and environment. Prompt chaining works because it breaks down complex tasks into smaller, focused steps. Each step uses a targeted prompt, improving reliability and control. The output from one step becomes the input for the next, creating a logical workflow. This divide-and-conquer strategy is foundational for building sophisticated, multi-step agentic systems that can plan, reason, and execute complex workflows. Use prompt chaining when a task is too complex for a single prompt, involves multiple processing stages, requires tool integration, or needs multi-step reasoning and state management. It's the go-to pattern for building agentic systems that handle intricate workflows and maintain context across steps. While prompt chaining handles linear workflows, real-world agents often need to make dynamic decisions. Routing introduces conditional logic, allowing agents to choose between multiple actions based on context, user input, or system state. This enables flexible, context-aware behavior, transforming agents from static executors into dynamic decision-makers. Routing can be implemented in several ways. LLM-based routing uses the model to classify input and select the next step. Embedding-based routing compares semantic similarity. Rule-based routing applies predefined logic, and machine learning-based routing uses trained classifiers. Frameworks like LangChain, LangGraph, and Google ADK provide explicit constructs for managing routing logic, enabling adaptive execution flows. Routing is essential in domains like virtual assistants, document processing, and multi-agent systems. For example, a customer support agent might classify a query and route it to the appropriate subagent, sales, technical support, or escalation. This logical arbitration is key to creating diverse, context-aware systems that can handle real-world variability. LangChain and Google ADK, you can build agents that route requests to specialized handlers based on intent. For instance, a coordinator agent analyzes a user's request and delegates it to a booking handler, info handler, or asks for clarification. This delegation pattern is fundamental in multi-agent architectures, enabling agents to triage and classify tasks efficiently. Routing transforms a static, predetermined execution path into a flexible, context-aware workflow. It's essential when an agent must decide between multiple workflows, tools, or subagents based on input or state. Use routing for applications that need to triage or classify requests, such as customer support bots or complex data pipelines. Many agentic tasks involve subtasks that can be executed simultaneously. Parallelization allows independent tasks like API calls, data processing, or subagent operations to run concurrently, reducing overall execution time. This pattern is vital for optimizing performance, especially when dealing with latency or large-scale data. Parallelization is powerful in scenarios like information gathering, data analysis, multi-API interaction, content generation, validation, multimodal processing, and A/B testing. For example, a travel planning agent can check flights, hotels, events, and restaurants at the same time, delivering a comprehensive plan much faster than sequential processing. With LangChain, you can define multiple runnable components and execute them in parallel. For example, summarize a topic, generate questions, and extract key terms simultaneously, then synthesize the results. This approach leverages asynchronous execution for efficient, scalable agentic workflows. Google ADK provides robust support for parallel execution. You can orchestrate multiple subagents to run concurrently, like researching renewable energy, electric vehicles, and carbon capture. Once all results are in, a merger agent synthesizes the findings into a structured report. This pattern is ideal for large-scale, multi-agent research and analysis. The real strength of agentic design comes from combining patterns. For example, use prompt chaining for sequential steps, routing for dynamic decisions, and parallelization for independent tasks. By orchestrating these patterns, you can build intelligent systems that are robust, flexible, and highly efficient. Prompt chaining breaks down complex tasks into focused steps, improving reliability and manageability. Each step uses the output of the previous, enabling multi-step reasoning and tool integration. Frameworks like LangChain and Google ADK make it easy to define and execute these sequences, laying the groundwork for advanced agentic systems. Routing enables agents to make dynamic decisions, adapting their behavior to diverse inputs and contexts. It's implemented through LLMs, rules, embeddings, or classifiers, and is essential for building versatile, context-aware applications. Mastering routing is key to creating agents that intelligently navigate complex scenarios. Parallelization boosts efficiency by running independent tasks concurrently. It's vital for optimizing performance in research, data processing, and multi-agent collaboration. Frameworks like LangChain and Google ADK provide the tools to implement parallel workflows, making your agents faster and more responsive. Mastering agentic design patterns is essential for building intelligent, autonomous systems. By understanding and applying prompt chaining, routing, and parallelization, you can create agents that are robust, adaptable, and ready for real-world challenges. These patterns are the building blocks of the next generation of AI applications. The evolution of agentic systems is just beginning. As agents become more generalist, personalized, embodied, and economically active, they will transform industries and daily life. The journey ahead is full of promise and responsibility. By building with purpose and integrity, we can ensure AI serves humanity and helps it progress. With the foundational patterns and practical frameworks at your fingertips, you're ready to start building. Experiment with the code, adapt the patterns, and create your own intelligent systems. The future of AI is in your hands. Let's build it together, one agentic pattern at a time. Agentic design patterns empower us to build intelligent systems that are not only powerful but also responsible and human-centric. By mastering these patterns, you're contributing to a future where technology augments human potential and drives meaningful progress. Thank you for joining this journey. Now, go create something extraordinary.